Welcome to the Candidate Screening Introduction to the Decision Model. For most of the people watching this candidate screening video, this will be the first time that you have heard of or seen the decision model. The purpose of this video isn't to provide a full understanding of all of the concepts in the decision model, but instead it is meant to provide a quick introduction to a few of the concepts that are fundamental to the decision model. While watching this video, feel free to pause or skip forwards or backwards as needed. This video and the concepts in it are only being covered to prepare you for the questions in Part 2 of the candidate screening. Once you feel comfortable with the content, you should advance to the next part of the screening. The first question you probably have is, what is the decision model? The decision model is a methodology and a graphical notation that allows for an independent representation of business logic. The graphical nature of the decision model makes it simple to create models, which means it makes it simple to build a graphical representation of business logic. It is this graphical notation that makes business logic easy to read and easy to interpret. The standardization of the notation allows for anyone that is familiar with the decision model to understand the business logic for industries or even areas of a business that they have never been exposed to before. To go along with the graphical notation, the decision model has 15 rigorous principles that work together to ensure business alignment across the various elements that make up the model. It is these same principles that allow for an error-free and technology-agnostic implementation of decision models. The next thing I'd like to explain is what we mean when we say business logic. Business logic is the means by which the business derives conclusions from conditions. A very simple example is listed here, where one condition leads to one conclusion. The condition here is policy underwriting risk is non-standard, and the conclusion is policy underwriting method is manual renewal process. The business logic statement is, when policy underwriting risk is non-standard, then policy underwriting method is manual renewal process. This is a simple case. We will take a look at a more complex case on the next slide. Using the decision model, business logic statements are written as rows in a table. This table is called a rule family. A rule family is a two-dimensional structure that represents logic in its atomic form. This means that logic is written in an unambiguous way to maximize its reusability, while being as simple as possible without any information or meaning being lost. One of the organizing principles of the decision model is the use of a single conclusion column. The use of a single conclusion column allows each rule family to be named based on its conclusion. We name the rule family after this conclusion because the conclusion is the only thing this rule family is used to determine. A rule family is about one thing and one thing only. This rule family is known as the policy renewal method rule family. To read a rule family, we start with the first row and go across the columns. As we go across the columns in a row, we would AND together the conditions. As you read down the rows, you would OR together each of the rows. A rule family's rows and columns can be rearranged without changing the result of the rule family. For example, I will read the first two rows. If policy underwriting risk is standard and policy pricing within bounds is yes, and manual underwriting indicator is off, then policy renewal method is automatic renewal process. Or, if policy underwriting risk is non-standard, then policy renewal method is manual renewal process. You should notice that as I read the second row, I didn't mention values for the conditions of policy pricing within bounds and manual underwriting indicator. These conditions are blank in the second row, which means that if policy underwriting risk is non-standard, then it doesn't matter what the other conditions are because policy renewal method is manual. The same could be said for the third and fourth rows. A condition should only be populated on a row if it will have an impact on the conclusion. You can see that all three conditions in this rule family impact the result of the conclusion. If a condition has no impact on the conclusion, it shouldn't be included in the rule family. When evaluating a rule family, all rows need to be evaluated to determine if they are true or false. It is possible for one or more rows to be true, but all of the rows that are true must have the same conclusion. If multiple rows could be true, and those rows have different conclusions, then there is a conflict. These conflicts can occur for two reasons. One, the model is incorrectly built, or two, the business rules the model represents are incorrect. Either way, if you have a conflict, it means that the logic is incorrect. Let's take a look at how you would evaluate a rule family. If we take the three conditions and we provide values for each of them, then we can evaluate which of the rows are true. Here we have policy underwriting risk with a value of non-standard, policy pricing within bounds with a value of no, and manual underwriting indicator with a value of off. If we evaluate each row using these values, we can determine policy renewal method. For the first row, we can see that with values of non-standard, no, and off, the first row is not true. If we go to the second row, you can see that the first condition is the only one populated on this row, and it has a value of non-standard. So the second row would be considered true. If we evaluate the third row, policy pricing within bounds is the only populated condition, and here the value is no, which is the same as our sample values, and so this row would be true. On the fourth row, manual underwriting indicator is off, and so this row is also not true. So looking at the overall evaluation of all of the rows, you can see that two rows are true and they have the same conclusion, which means that given these inputs, the policy renewal method rule family would evaluate to manual renewal process. Now that you know how to read a rule family, I would like to explain some of the notation used when depicting a rule family. You will notice that two of the conditions in the policy renewal method rule family are underlined, and one of them is not underlined. Here, the condition manual underwriting indicator may be persisted in a database, and that's why it is not underlined. The other two conditions, policy underwriting risk and policy pricing within bounds, are underlined, and so you may be curious, where do the values for these conditions come from? We underline our condition headers if the values for those conditions come from other rule families, or if they are derived from other business rules. An example for interim data versus persistent data is if you were to ask to provide your name, then that is information you know. If you were asked to provide your qualifications for a loan, then that is information that you would have to derive based on the rules for qualifying for a loan. Here you can see the rule family for policy pricing within bounds. You can see it has conditions for policy tier and policy discount. Policy tier is not underlined to let you know that its values are persisted in a database, whereas policy discount is underlined to let you know that it would have a rule family to support it as well. Rule families can be naturally linked together with what we call an inferential relationship. This allows one rule family to be supported by other rule families. Now that we've gone through rule families and some of the ways that they can be linked together, I'd like to do a quick recap of a few key principles of the decision model. Number 1, each rule family has one and only one conclusion. Number 2, each condition in a rule family should be independent of the others. Number 3, all populated conditions must have an impact on the conclusion. Otherwise they are redundant and should not be a part of the rule family. Number 4, a rule family must be complete. All possible condition value combinations must be covered. Number 5, there should be no combination of condition values that will result in conflicting conclusions. And number 6, there are many valid operators: is not, is in, equal to, less than, greater than, less than or equal to, and is between are just a few of the many valid operators. At this point, I would like to conclude part 1 of the intro video for the candidate screening and allow you to proceed into part 2.